All right, here am I. Good morning. So this is a quick instructional video on how to do the genotype analysis for the Lulu, the Lioness activity, in case you were absent or maybe you're getting back to it and you don't quite remember what happened in class. So I'm just going to access the assignment here. So hopefully you either have a paper copy or you can access it yourself. Remember, from year to year, the dates may be different, but this year this was Tuesday the 13th. Okay. So this is actually just a paper activity. So you're going to go ahead and open this if you don't have a paper copy. Hold on. As usual, we're going to rename your copy with your name here so that we can find it easily if you need it. And then we're going to move it into your own folder so your drive doesn't get all confusing. So we're going to go to the 22-23 school year. You should have a biology folder, and you're going to move it right there. All right. So this is the handout, like I said. This is the handout that was given in class. But you need the data in order to do this. So we've got two separate handouts going on here. The first one is, it looks like it's all done on the front, but that's because we did an example in class, which I'll go through with you here. So the first one is the packet that students will be filling out. And then this one is the data for all of the lions and the male and female lions in the activity. So you've got, here we go. Here it is. Just a reminder, we're looking at 4 genes here, and we'll talk about why that's important a little bit later. And for each gene, you've got your lions over here. So they're numbered because, like 630 is Lulu, but researchers generally number their organisms. So you've got 3 females here and 3 males here. For each gene that we're looking at, and lions, like humans, have thousands of genes, but we're just looking at 4 here. For each gene, you have 2 alleles. A reminder, a gene codes for a particular trait. An allele is just the version. So maybe the gene is eye color and the alleles are blue or brown. Or maybe the gene is whether you can curl your tongue, which I can't demonstrate because I can't do it. And your alleles would be yes, you can do it, or no, you cannot. So everyone has 2 alleles for every gene. Those alleles come from your biological parents. Many times you'll see alleles written as a capital, 2 capitals, 2 lowercase, or a capital and lowercase letter. In this activity, they're actually written as different letters, just 2 different ways to notate the same thing, okay? So this line, for example, for gene 1 has an A allele and a B allele. For gene 2, an M and an N. For gene 3, 2 S's, and for gene 4, 2 D's. So these alleles for this particular lion would have come from her parents. But we're looking at who was she the parent of? So we're going to go back to this lesson. And I'm actually going to delete this information because I'm going to run through the activity with you, and you can follow along on your sheet, which is filled out. All right. I'm also going to pull this down and shrink it up. Sorry, thank you for your patience. So we can look at both things at the same time. Okay. And we might need to get my silly mug out of the way here. Okay, there we go. All right. So for gene 1, we're looking at cubs. Fudge. Hold on. Disappearing window. Hold on. Now we're ready. Sorry. For gene 1, the cub, we're looking to find out who the parents of cub 711 are. And the cub has a B and a B. So we're going to start with lion 120 or 628, sorry. This cub has an A and B. So she could be the mom based on this one gene. Because she has an A and B and the cub has a B. So if she was the mom, she would have given the B to the cub. So we're going to put a B in that box. And then I'm going to go gene by gene. Okay. For lion 630, this lion had a B and a B. and this cub had a B and a B. So this lion could have given that cub a B as well. This was Lulu, actually. Sorry, bear with me one sec, guys. Okay, and then 687. This cub had a C, or this lion had a C and a C. So this lion can't be cub 711's mother because this lion only had C alleles, and the cub had to get those B alleles, one from mom, one from dad. So since this lion could only give C alleles to her babies, this can't be that cub's mom. So we're going to put an X in that box, okay? And so here's the beauty. And I'm going to switch to the pen now. Sorry, I should have done that from the start. If this gene, if 687 couldn't be the mom of cub 711 because it didn't have the right allele for this gene, you know it's not the mom. So you can eliminate her right away, all right? But we still are between these two moms. So we're going to have to go on to the next gene. That's one of the reasons it's important to have more than one gene, right? So for gene 2, cub has an M and an O allele. So got an M from its mom or dad and an O from its mom or dad, one from the other. You don't know which is which. It's not like the first one's the mom and the second one's the dad. So we're going to now look at our females. Oh, wow. Well, look at this. Every mom has the same alleles here. So that's not super helpful for this gene. Well, we've already eliminated cub 687. And this cub has an M and an O, so they had to get the M from the mom because the moms don't even have O's. So we're going to put M, because we know the moms, in this case, give an M. We're still between these two moms. We don't know who it is yet. Okay, so now we're going to go on to gene 3. For gene 3, the cub has an S and a T. For gene 3, lion 628 has 2 S's. So could she have given the S to this baby? Sure could have. So we're going to put an S there. That's the gene from the mom. This mom over here has an S and a U. Well, could she have given that S? Sure could have. So there we go. We still don't know anything. We're still between 628 and 630. For gene 4, the cub has an E and an H. Okay. Look at this. 628 only has D's. So all of the eggs from 628 had D's in them. So 628 could not be this lion's mom. So we're going to X that out, and that means she's out of the running. Okay. Let's just make sure this one works. So we've got an E or an H, and look at that. This cub also has an E or an H. So the mom could have given the E or the H. We don't know which because both the cub and the mom have the same genes. So we have to leave the E and the H at that point. Okay. So now we know that the mom is 630, okay, for this lion. All right. Now we got to figure out the dad, okay? So again, here's our cub data. We've got BB, MO, ST, EH. So to start, the dad, we can kind of figure some stuff out because the dad, because we already know what the mom gave in most cases. All right, sorry, I know my screen's a little crowded here, but just try to bear with me. You can pause and rewind if you need to. So here the cub had a B and a B, and the mom gave a B. So we know that the dad had to give a B because the cub had 2 B's, got 1 B from mom. So it has to be a B. For the second gene, the cub had an M and O. The mom gave the M because the mom only had the M to give. Every time. Scares me every single time. So the dad had to give the O, the biological dad, obviously. Okay. That had to give the O because the cub has an M and an O. Mom already gave the M. So we know the dad has to give an O. Okay. Gene 3, S and a T. Cub has an S and a T. Mom gave the S, right? Because the only thing the mom had to give was an S and a U. So she gave the S. Well, so now we know that the dad had to give that T, right? Because you get you get one set of genes from mom, one set of genes from dad. So you have 2 of every gene, 2 alleles for every gene, and you get one from each parent. Okay, last one. We had EH on this gene, and the mom gave either the E or the H. We don't know. So the dad also had to give the other one, but since we don't know what the mom gave, we can't really eliminate and figure out what the dad needs to give. So we got to stick with that. Okay, so we're going to scroll up, and here we go. So this is what our dad has to have, B-O-T, and then an E or an H. So you can do a couple of things. You can, it's messing up. You can kind of look through and see who has a B, O, a T, or an E or an H, but it's a little messy, and it's sometimes easier if you actually go through it and write it down. So we're going to look at Father 631. Father 631, 2 A's. Guess what? Not the dad. He needs a B. Doesn't have it. So look at that. We're just going to eliminate him. Okay? He's out. He is not the father. Okay? 633 for gene 1. He's got a B and a C, and we needed a B. So far, could be the dad. Let's go line by line in this one. So I'll do all this lion's genes instead of gene by gene. Gene 2, dad needs to give an O. Look at that. Dad has an O. So 633 could still be the dad. Gene 3, dad has to give a T. This dad has an S and a T, so he's still in the running. He could be the dad. And then gene 4, the dad needs to give either an E or H. And this dad has a D or an E, so he's got that E that we need. So we're going to give that E. So it looks like, sorry about my writing, it looks like 633 is the father, and this one was already filled out, so you have it there. But I just want to run through the last one just so you know how to check your work. 668 did have a B, so he could have given a B. Gene 2 needed an O. 668 had an O, could have given an O. Gene 3, we needed a T. Guess what? No T. So on gene 3, that one rules out 668. All right, so 633 is the father. We also know now that the father gave the E for this gene, which means the mother gave the H. All right, so we know that cub 711 has 630 as the mom and 633 as the dad. I know it seems kind of like a lot, but it's like a puzzle and a game, and you'll get it. You'll get it. You have a lot of practice on this. How do we get rid of that? I'll figure that out later. You guys don't need to deal with that. Hold on, actually. So here's what you're going to do. Oh my gosh, I'm sorry. I'm going crazy. So yours is all filled out for that top one because that's your example. So you have now 4 cubs to figure out. You have cub 709, 710, 712, and 713. You're going to fill out all those. The data is here if you have it. You have it, or you can click on it, and that data is going to be the same. You're going to use the same parent data for the whole entire activity. Go through it carefully, and if something, they all work. So if something doesn't make sense, you've probably made a small mistake. So just go back through, maybe watch the example over again, and don't skip steps. If you really get it, you can maybe skip some steps, but take your time. Let us know if you have any questions. And then at the end, you just have 4 quick questions to answer. Please be sure to explain and use evidence from the activity to back up what you're saying. All right, so you want to get this completed. You can hand it in to us hard copy if you want, or you can complete it digitally and hand it into us on Schoology in that way. Let us know, like I said, if you have any questions. All right, good luck. And you can always rewind and rewatch.